In the previous lesson, we explored the fundamental elements of Three.js. Today, we're going to implement them in actual code. It's finally time to code for the first time. For this lesson, please download the source code provided. Once unzipped, you'll find two folders, CDN and Vite. As in the previous lesson, the folder CDN contains code for using CDN, and the folder Vite has code for using Vite. We've seen both methods in previous lessons, right? I will proceed using Vite. You can also use a CDN as we learned in the last lesson. If you're using a CDN, there might be some differences in the code. In this case, I'll mention it for CDN users, but if you're using Vite like me, you won't have to care about them at all. Open the folder Vite in VS Code. This folder has been set up as our project directory. We'll begin by installing the required packages. As we did last time, refer to the README for installation instructions. Open the terminal and install Vite. Once that's done, we'll also install Three.js. Start the server using the npm start command. Opening the web page, you'll notice nothing appears. That's because our main.js file is currently empty. If you're unfamiliar with Three.js code, don't worry, we'll be writing it together, step by step. Our development source code is inside the folder src. Let's begin with the index.html file. You can see main CSS is linked, and the main.js is connected as a module type. Within the body, there's a single canvas tag with the ID 3 canvas. This canvas is where we'll render our Three.js application. Let's check out the main CSS. We've set the body's margin to 0 to remove any spacing. We've also positioned the canvas as absolute within the browser and added a background color to easily identify the canvas area. Main.js is empty, the heart of our application. We'll code it together to get familiar with Three.js development. Alright, let's dive into coding. Start by importing the Three.js module as 3. First, we'll create a renderer that will be responsible for rendering the scene. To do this, we need a canvas object, which we'll assign to a constant named canvas. Declare a constant called renderer and assign a renderer instance. The renderer instance is created using the constructor function WebGL_renderer. Since we imported Three.js under the name 3, we should use 3 first, right? Set our canvas as the value for the canvas attribute and enable anti-aliasing to ensure smooth graphics. In JavaScript, if a property and value have the same name, we can simply write it once like this. Adjust the renderer's size to fit the browser window using the setSize method. And apply the setPixel ratio method to make the image appear sharp on high-resolution displays. Set to 2 if the value is greater than 1, otherwise set to 1. On my MacBook display, it's set to 2, which means the width and height are set to twice the size of what our eyes see. Next, create a scene and assign it to a constant name scene. Now, let's create the camera. Three.js provides several types, but we'll use the most common one, the perspective camera. This camera mimics the way human eyes perceive the world, making distant objects appear smaller than closer ones. It's the camera that creates the sense of depth and perspective we're most familiar with. Some values need to be set when creating the camera. First is the field of view, which defines how much of the scene is captured by the camera, typically ranging from 35 degrees to 75 degrees. Next is the aspect ratio, usually the rendered screen width divided by its height. Lastly, we have near and far values defining the closest and farthest distances the camera can render. Objects outside this range won't be visible. We'll set near to 0.1 and far to 1000. Adjust the camera's position using X, Y, and Z. You can also use the set method of position to set the X, Y, and Z values all at once. Lastly, add the camera to the scene using the scene's add method. When the renderer invokes the render method using the scene and camera, it's rendered. Congratulations! But as you can see, there's nothing there, just a black screen. Now we're going to create a visible object, a mesh. Remember that a mesh is made up of a geometry and a material. We'll create a cube-shaped mesh. Three.js provides various forms of geometry. You can test different geometries on the documentation page. Let's take a look at some commonly used geometries. Box geometry is a standard cube. It accepts the width, height, and depth as arguments for creating the geometry. Sphere geometry is a 3D spherical geometry. It takes parameters such as radius and the number of segments split by latitude and longitude. Plane geometry is a 2D flat surface. It accepts the width and height of the plane and the number of segments as arguments. Cylinder geometry is a cylinder with circular top and bottom faces. It accepts arguments like the radius of the bottom, the radius of the top, the height, and the number of segments. Cone geometry is a cone-shaped geometry. It takes the radius of the base, the height, and the number of segments as arguments. And there are many other geometries, so take a look. We'll use box geometry with a width of 2, height of 2, and depth of 2. For the material, we will use the most basic material, mesh basic material with a color set to firebrick. Let's add this box mesh to the scene. Let's add a mesh to act as the ground. We'll use plane geometry, a flat square shape, with dimensions 10 by 10. For the material, like the box mesh, we'll use mesh basic material. Add the ground mesh to the scene as well. You can also add multiple meshes at once. But something seems off, right? The ground is standing vertically. Plane geometry by default is a vertically standing plane. To make it lie flat like the ground, we need to adjust its rotation. We'll rotate it on the x-axis by setting the value of rotation x. We need to rotate it by -90 degrees. In Three.js, angles are in radians. We'll use the math-utils degree to radian method to convert the familiar 360-degree angle to radians. So, we've rotated it by -90 degrees. You can directly use math pi divide by 2, since math pi in radians is 180 degrees. Another odd thing, the box is half buried. If you haven't set the position of the mesh, its coordinates are x equals 0, y equals 0, z equals 0. This point, which represents the mesh's coordinates, is in the center of the mesh. Given the box's height is 2, setting the position y to half of that, which is 1, resolves the issue. We've applied a mesh basic material, and it kind of looks like a piece of paper, and it doesn't feel very three-dimensional, because mesh basic material doesn't have shadows. So to make it more three-dimensional, I'm going to change the material to mesh Lambert material, which is a matte material. Oops, I changed the material to mesh Lambert material, and the box mesh turned black. Let's also change the ground mesh. It also turned black. The reason this happened is that the other materials, except for the mesh basic material, need a light source. We need to add a light, right? In Three.js, there are various types of lights. Let's briefly look at some commonly used ones. Ambient light provides ambient illumination, evenly lighting all objects within the scene. It does not make shadows. It is commonly used in combination with other light sources to set the overall brightness of the scene. Directional light acts like a distant light source, similar to sunlight. It makes light coming from the same direction for all objects. Shadows can be generated with it. Point light is a light source that radiates light in all directions from a single point. It affects objects around the light source and can also make shadows. Spotlight makes a conical beam of light. It is similar to the spotlight you might see on a musical stage that focuses solely on the lead actor. The angle and distance can be adjusted to determine the intensity of the light, and it can also make shadows. You can use these various lights individually or combine two or more to achieve the desired effect. Often, multiple lights are used together. Now, back to the code. First, let's create an ambient light to determine the overall tone of the scene. Set the color to white and the intensity to 1. Let's add the ambient light to the scene. Adjust the color and intensity as you like. Next, we'll create a directional light, similar to sunlight. Like ambient light, set the color and intensity. We'll also set its position. The position will be roughly here. Lastly, let's handle shadows. The light is around here, So the shadow is going to be on this side. To make shadows, you must first set the renderer's shadow map enabled to true. Oh, but the shadows are still missing. There are additional steps to create shadows. The light and mesh that make shadows must have the shadow setting true. And where the shadows appear, the receive shadow setting must be true. Set cast shadow to true for the directionality and box mesh. And set receive shadow to true for the ground mesh. Now the shadows appear correctly. Let's also adjust the position of the camera. The camera has moved to the left, but what if we want to center the shot on that box? So, using the camera's look at method, we have the camera looking at the position of the box mesh. We'll also change the background color, which can be done by assigning an instance of a color object to the background property of the scene. There are several different color formats, so use whatever you're comfortable with. I'll simply write white. So there you have it, a basic scene for Three.js. Until next time. This lesson is the basic part of build a first-person view 3D website with Three.js. If you're interested in the full course, check out the link in the video description. And don't worry, you can still learn the basics of Three.js by watching this YouTube playlist without watching the full course.